Welcome back everyone. Let's do one more example on KNN, which comes under instance-based learning. This example again we are doing for discrete value target function itself. Okay. So here, the only change that I made in the previous example is the target label. So the target label I have changed it as eligible. So okay, so let us assume that so there is a notification and there are certain age groups of people who wants to apply for that. Okay, so the eligibility is given here. Okay, so the person, if he is falling less than or equals to 40, we have made them as eligible. Okay, and he should be greater than an age of 18. 18 to 40 is eligible, others are not eligible. So based on that, we have given a binary labeling here. Okay, so here my example data set is only two-dimensional one. It is not an n-dimensional space. It is containing only two-dimensional space and my target label is purely binary. So in this case, let us calculate the KNN using Euclidean distance. Okay. So here once again, the new instance that I have taken is again Ria, age is 5 and K value as 3. Okay. So let us check whether this person is eligible to apply for this or not based on his age. So let's see what does our algorithm say. Okay. So as we already know, our algorithm contains two parts. One is the training algorithm. Other one is the classification algorithm. So in the training algorithm, simply it will store all this information. So it will store the examples. And similar to the previous one, here again, name is not required for us for computation. The only thing that I need is age. So let me indicate it as X1 and let me indicate gender as Y1. So the new example is Ria and age is 5. Okay. So from this, I can get the gender as female, which is 1. So now my X2 is 5 and my Y2 is 1. Okay. Age we are taking as X, gender we are taking as Y2. So now the formula for distance calculation, we already aware, right? So it is square root of x1 minus x2 whole square plus y1 minus y2 whole square. So now let's calculate for the first instance. Okay. So it is age2 minus age1 whole square plus gender2 minus gender1 whole square, which is 5 minus 32 whole square plus 1 minus 0 whole square. If you simplify that, we are getting a value of 27.02. Similarly, for the next example, if we compute, it is 5 minus 40 plus 1 minus 0. So similarly, we should calculate for all other. And here the values are labeled. So these are the distances that we have. And once again, we know that the K value is 3. So only the nearest 3 I should consider. So again, we are considering 9. Okay, so let's take this value as 1. Okay, because this is the first nearest point. So this is 1. Let's take this 10 as 2 and this as 3. So now for these 3 values, we have to compute the result of the distance. Okay, so using the classification algorithm, we need to compute. So what does the formula say? So f cap of xq has to be computed. What is xq? The new instance that we have taken. So this is our xq. So for this, the target function value we are computing. So for that, what is the formula? So the formula is argmax V belongs to capital V. So here, what are the possible values that we have? We have SR no summation of dou of V comma F of XI. So this we need to calculate. So first let us calculate for V value, yes, and then we calculate for V value of no. Okay. So let's calculate F cap of X cube for the case of S. Okay. So that is once again summation of dou of V. So the V value that we are taking is as S. Okay. Then f of xi, the target label for the first nearest distance, that is also yes. Comma, dou of V value is yes. The next target label value with distance to the next target label value is no. So I'm writing here no. And then the next target label, that is dou of V value is 1, f of xi for distance 3, it is no. So now we should calculate the dou values of all this and we should sum it. Okay, so when A is equals to B, so this, the first parameter is A, the second one is B, right? Whenever A is equals to B, the result of dou is 1, otherwise it is 0 as per the algorithm. So this is a continuation of previous lecture. If you have not watched, please go back and watch the previous lecture. There we have the algorithm. So we are tracing the same algorithm here. Okay, so let's do the summation. The first value is 0. Sorry, first is 1. Because it is S and S, A is equals to B. So the value is 1. Plus the second is S or no. S and no, they are not equal. So it is 0. The third is also S and no. So the value is 0. So when I sum it, I'm getting a value of 1. Next, let us calculate F cap of XQ for the case of no. So now let's take the V value as no. Our V value now is no. So we are calculating F cap of X cube, which is sigma dou of. So now my V value is no, and F of Xi for the first instance or for the first distance, it is yes. Similarly, for the second one, V value is no, and the target label value for the second nearest distance is no. And similarly, for the third one, V value is no, and for the third nearest distance, the target label value is also no. So now the first dou value, no and S. So it is not equal. So the result is 0. The second case, no and no, the result is 1. Since A is equals to B. The third case, no and no, the result is 1 since A is equals to B. If I sum it, I'm getting a value of 2. So now the result of F cap of XQ is R max of 1, 2. So out of this, 2 is the maximum. So this 2 I got for which value of V? I got it for no. So now my new instance XQ is labeled, will be labeled as no. So the target label for the XQ is no. So if you are adding that new instance here, so it will be Ria. The age is 5, female, and the target label is no. So this is how our KNN is going to work. Hope you followed the lecture. If you have any queries, please let me know in the comment section. So now, based on this, I just want to show you one more plot. Yeah. So this we are calling as Voronoi diagram. So here you can see, if I take the K value as 1, so these are some data points, okay? So I have taken K value as 1. So I made different groups. So you can see in each group, I have only a single data point. So this I am calling as one nearest neighbor, okay? So here, since I am taking only one point, so here you can see the result Suppose if I have my x cube here, okay. So my x cube based on one nearest neighbor is classified as positive. For example, let's take x cube here in this case. So this is a 5 nearest neighbor. So you can see I made a group of 5 into a single cluster. Okay, so this is 5 nearest neighbor. 5 points I have grouped in this circle. You can see 3 negative points are there, 2 positive points are there. And this is my x cube. Okay, so now based on this, what can I say? So here I have 2 positive points and 3 negative points. Just now we have seen the argmax. Okay, so since I have 3 negative points, definitely the majority was treated as a no case only. So that means the result of x cube will be negative in this case. X cube will be classified as negative. Whereas in the one nearest neighbor, x cube is classified as positive. And here if you see, the decision surface is a convex polygon. Always what this convex polyhedron is telling is, it is giving us a set of query points. Here xq is my query point or the new instance. Okay, so that is indicated in my polyhedron. So whenever we are following this kind of visual representation, so that is called as Voronoi diagram. So this we can use for KNN classification in case of discrete value target function. For the continuous also you can follow this with little modification. Hope you enjoyed the lecture. If you are finding my lectures useful or if you are finding it lengthy or whatever you want to suggest me, you can just comment that in the comment section. Thanks for watching. Do like, share and subscribe.